Okay, I'm going to send these notes out to y'all after we have the session. These are some of the things I'd like to cover. And of course, we'll, let's see. I see one thing I left out, and one was ask you to ask questions. But we're going to go over test one a little bit and show you some data on it. I want to have a quick recap of how to keep up. Let's see, need to hide the video panel. Okay. And I wanted to maybe do some clarification on some things. And then talk about the calculator and how to make sure we have accurate, careful calculations. And then maybe preview what we're going to be doing next week. Now, this is data on the test. The average grade was about 75, which is generally considered pretty good. And as you can see, we had more A's and B's than any other particular grade. Although we did have a number of students who didn't do as well as I'm sure they wanted to. And looking at those grades, almost every one of them did not do all the homework on time, or maybe even had a low grade anyway. However, there were 2 or 3 that had done very well on the homework, but somehow missed a few things on the test. And I think I'll send an email about this out. If you were one of the ones who made lower, but still did the homework, we need to figure out whether that was a silly error or something, or maybe something was not right with your calculator, or maybe you were using the wrong formula. So one of the things I want everybody to do is look at the tests that you can see and figure out what you did wrong and what the root cause of it was. But in talking with Dr. Andrews, who's the chair of the math department, he said this is probably a little higher average grade than he usually sees on the first test. Does anybody have any comment on the test? Does anybody have a comment? Oh, you may or may not have looked at the videos for next week yet. What you have over here is what you will learn how to calculate. It's called a box plot. And the first thing you calculate is a median score. And that's the score that's right in the middle of all the data. And the median was 78. The highest grade was 100. And the lowest grade was 17. And this is the 25% point called the first quartile. In other words, 25% made below first quartile, which was 63. And of course, the median, this is 50% of the people. And then the third quartile, which is a 75% point, 25% made 95 or higher. So one of the things we're doing in this data unit is learning how to look at data and display it. Does anybody have any comments on the calculator? Do y'all feel comfortable with it? Don't hear anybody say anything. Miranda, does it work okay for you?
I actually have a different calculator, but it's the same type of calculator. It's
what do you use?
I can't think of the model number. I'd have to go get it, but it's a Casio, but the features are almost the same exactly as the TI.
So you can see
The whole
the equations that you're putting in.
That's right.
And it allows you to put in like a fractional expression.
It does, yes, sir.
And okay. Well, it's sort of interesting. All of my calculus and pre-calculus classes used a TI 83, 84 graphing calculator. And you don't necessarily need that for this course because we're not going to graph a whole lot, but we will graph some. But this calculator we've got in this course that we sort of recommend if you don't have one is the TI 80XS. It's about $15 at Walmart. And it's the first time I had seen it when I started teaching this course this semester. And I was pretty impressed with what a $15 calculator could do. And I think all the kinds of calculations we're going to have to do in this course, it can do. The only thing it doesn't do is sort the data after you put it in. But it will do a lot of calculations. So, Miranda, will it do statistics on input data?
I'm not sure yet.
You might want to check it. Okay. One of the students who took this class did not have this calculator, but she found one on her iPhone that was called the Calculator Plus. I think they only make it for the iPhone. And I didn't have an iPhone, and I couldn't put it on my Samsung, but my wife had one. So I put it on her iPhone, and it does the things that Miranda was just talking about. It could do all these calculations, except it would not take the data that at least I couldn't find a way for it to do it. This young lady in the course, I think she may go out and buy the $15 one. Corey, what kind of calculator did you use?
I've got TI 83.
Oh, an 83, okay. You know, that is a classical calculator.
Classic calculator for a classic kind of guy.
What's that now?
I said classic calculator for a classic kind of guy.
It's been around a long time. I was absolutely amazed when I first saw it about 15, 16 years ago, and they've had upgrades on how it works. Are you able to do all of these equations with that?
Yes, sir.
Okay.
So far.
You got to watch your parentheses, I think. Okay.
Yes, sir.
So I think everybody needs to sort of review the calculator And I'm going to show you some calculations we're going to be doing for next week, and just to give you sort of a preview. But I was pretty pleased with these grades, except the ones who didn't do as well. I want you to stay in the course, and I want you to ask for help or try to figure out why the calculations weren't quite right. And I bet you we can find the cause. But to me, the thing to do is you got to do the homework, which is here's how to keep up. For this particular test, there were maybe 3 or 4 students that didn't realize we had a test. They weren't checking their email every day. They weren't checking D2L. And I had to call them and see if they're planning to take the test. You need to do the homework on time and also do the practice test. I just put up a practice test for test 2, and that's something y'all can look at next week. And I've got to make a video for it. But I want you to ask questions if you have doubts on how to work some of the problems. There were some students that weren't sure where to go to see everything. And to tell you the truth, I would do this to run the course. You don't have to go to my homepage, but that's one way to get to it. You could bookmark this, but bookmark the quantitative skills and reasoning homepage. And from this page, you can run everything. You got your daily schedule, you got your syllabus. Here's your test 1 practice video. And I just put up the practice test for test 2. And it's got about 25 questions in there. We may even look at some of them. But I would always go to the daily schedule and see what you need to be doing for that week. For instance, we're here the week of the 9th. I hope that you've been watching these 2 videos here. For each of these videos, you can click on the notes. And you can take notes on my notes. This is some of the things that were in the video. And next week, okay, we did tables and graphs, and then there were notes for that. And you may have already seen some of this. And then next week, we're going to be looking at measure of center and variation and what we call the 5-number summary. The 5-number summary is what I just showed you in the box plot. It had the minimum, the maximum, the median, the 25 percentile, and the 75 percentile. But for each of these things you need to watch, you can also click on the notes. The other thing you can do is you get ready to do the homework, you just click on this and you'll go to My Open Math. And this is where I log in. Okay, I plan to have somebody ask questions. Anybody have a question about any problem? Does anybody have a question?
No, sir, not right now.
Not right now? Okay. Have you watched the first 2 videos?
Yes, sir.
Okay. I'm looking for a contract with Netflix to put these up on Netflix. You think I'll make any money on that? Probably not. Okay. One of the things I wanted to look at was the sampling clarification. This was covered in the videos this week. We have ways to take samples from your population. You know, the population is the group that you're trying to study, and there are all kinds of ways of doing sampling. And for instance, you can do random telephone sampling. But two of the sampling methods that were included in the video and in the notes was one, stratified sampling and cluster sampling. In stratified sampling, you divide the population into a number of subgroups. And the key word is random samples are taken from each subgroup. So with sample size proportional to the size of the subgroup in the population. Now, cluster sampling, the population is divided into subgroups, and a set of subgroups are selected to be in the sample. And I think you ought to call this a subset of the subgroups. Not all. And the reason you might use cluster sampling is maybe you don't have enough funds to sample every subgroup. You know, figuring out who's going to win an election by using sampling techniques is a really touchy kind of thing, very sensitive to how well you do your sampling. And a lot of elections have been miscalled because the sampling technique was not all that accurate. Let's look at stratified sampling. You divide the population into, say, 4 subgroups, and you take samples from each one of them. You don't neglect any one of the subgroup. In cluster sampling, you may be divided into 4 groups, but you only take samples from, say, 2 or a subset. In fact, just think of this New York City. New York City has all kind of precincts in it. You might number them. Gosh, I don't even know. They may have so many. They may have 100 precincts. And you may not be able to afford to sample every precinct, but you might take some that you think might be representative. And this is called cluster. So on the test you're going to be taking in a couple of weeks, there'll be some questions on there on what kind of sampling you're doing. Anybody got any questions on that?
I don't.
Okay, okay. And I guess if anybody does, just chime in.
No, sir, I don't either.
If you looked at the videos, and you don't have to look at the videos in order to have seen all kinds of charts in the media, on the internet. You can just pull up all kinds of things on the internet, and see all kinds of data about various populations. You see sums on the average age of the average life expectancy, the height of people, the weight of people, percentage of people that have heart disease, and so forth. Here's a chart on the height of women and men. I'm not even sure where this is, whether it's US or the world, but I think everybody knows the average height of women and men are different, and they have various distributions. And so we're going to be studying next week on variation. Has anybody heard of the standard deviation? That's one thing you're going to have to calculate. And I'm going to show you how to calculate it in a minute and sort of emphasize the fact that you need to have a very good calculator that can do this. By the way, if the variation, I think, can be illustrated from this chart. Suppose almost all women had the same height and very little variation, or almost all the same height. So their distribution would look like this as opposed to what it really is. If all men, hello? Did somebody say something? Okay, I thought I heard something. If all men had pretty much the same height, their distribution would look like this as opposed to a wide variation. Now, here's what I wanted to illustrate. When you look at variation in data, we're all going to have to be able to calculate the standard deviation. And standard deviation is a measure of how far each data value deviates from the mean. And I think everybody knows the mean is x1 plus x2 plus x3. Add up all the data points from 1 to n and divide by n. In other words, look at all your data, and I'm sure you've been calculating average for years and years. So one of the things you'll be doing is calculating the mean. That's not too hard to do on your calculator if you put your data in accurately, but it's probably nice to be able to key it in and then ask the calculator to do it for you. Now, so you're going to take every data point, x, and subtract off x bar, which is the mean, and square it and add all that up. So here's the big thing you're going to do. The standard deviation is a sum of all the deviations from the mean squared. So if you got 100 points, you would have to calculate the mean or the average and subtract that from all the data points, square it, and divide it by n minus 1. And then take the square root of that, and that's called the standard deviation. If the standard deviation were 0, that means every one of the data points are exactly the same. There's no variation. Now, here's an example that came from one of the videos that you may or may not have seen. These are contract offers, or you could say salaries for workers, and you're asked to find the mean, the median, the mode, the range, and standard deviation. Now, I took all these numbers and put them in order. So it's always good if you can to put them in order from lowest to highest. So we have someone making 50,000 a year, 80,000 a year, 90,000 a year, 100,000 a year, and then I guess Bill Gates here who makes 10 million a year. Now, it's very easy to calculate the mean to be about 2 million, but you know that mean doesn't really characterize this group, because most of them are within about, at least $50,000 of one another. And this is called an outlier. So the outlier is the one that really is not exactly a part of the group. Now, you calculate the mean, and if you want to calculate the standard deviation, you've got to take every one of these values, subtract the mean, square it, and this is what you get when you square each one. In this case, it gets pretty big. You add them all up and divide by n-1, you get this, and then you take the square root and you get the standard deviation. Now, I don't want anybody to be taking a test that doesn't have a calculator that can actually calculate the standard deviation without you doing everything by hand. Miranda, do you know whether your calculator could do this?
I'll find out today, and if it won't, I'll go get the other calculator. They were just sold out every time I went and looked for it.
If anybody doesn't have the money, I'll loan you a little bit. No kidding, anybody that doesn't have the money for a $15 calculator, I will find a way to get you one, okay? But I think everybody can get one. What I'm going to do is bring up the calculator and put this data in. Since it's only 5 values, just bear with me for a second and I will put them in. On this calculator, you go to data, and notice I've got data already in the calculator. So I'm going to hit it again. I'm going to say clear L1. This has at least 3 lists in it. I just cleared L1. Now I want to clear L2. And now I want to clear L3. Now all the lists are clear now. Now I'm ready to put data in. And so I'm going to put 50,000. And then hit enter. I think I can hit return. You know, that worked. I'm hitting the return on my computer here. But I could also hit the enter key right here. Then I'm going to put 80,000. Enter. I'm going to put 90,000. I'm going to hit enter. Then I'm going to put 100,000. and hit enter. And then I'm going to put the big guy, 10 million. Here's where you need to really check your work to make sure you put it in accurately. And so now this says the next one I would put in would be the 6th number, but there are only 5 numbers. So we leave this right here. By the way, I think there's a way to make this just display. I guess if it gets up to 10 million, it may not display all the zeros. So we got the data in. So now we want to do the statistics on it. And we don't want to do this. First of all, we need to get the mean. So we're going to hit second stat, which is second data, which means you're going to do statistics on something. And we're just going to be doing one variable statistics. So I'm going to hit enter. And now it asks you which data list do you want to use, and you'll have to pick L1. That's where I put it. And we're going to do what we call one frequency. And hit enter, and then it calculate. We'll hit enter when it says calculate. And now it gives you the data on here. N is 5, the number of data points. X with a bar over it is the mean, the average, okay, which is 2,046,000. The standard deviation, which we see right here on the slide, is 4,400,000. Wow. Did I put something in wrong? This doesn't make any. See how you got to be very careful. 50,000. Anybody see my arrow? No, wait a minute. No, I didn't make an error. 50,000, 80,000, 90,000. Uh-oh. Anybody see my arrow? Who all sees my arrow? Miranda, you see it?
You've put 10,000 instead of 100?
Absolutely. Now, I didn't plan to do this. I didn't plan to make a mistake on purpose, but maybe it'll show you that if you don't watch, I'm going to put that in correctly. I'm going to put 100,000. Now, do I have 100,000 in right now? So I think we're cool. Now, after you check your data, now, if you did what I just did, you could screw up on the test. You might get the mean pretty far off. Now, if I see you got it so close that it's pretty obvious what kind of silly mistake you made, I might give you part credit on it. But anyway, we're going to do the calculations on this, and you get second stat, go through the variable statistics again. L1 is already picked. Frequency 1 is already picked. Now pick calculate. And now this is the true standard deviation. And the true mean. In other words, the mean is 2,064,000, which is what I have over here on the slide. So now you go on down. it's got a number of sigma x here, which you don't need to worry about right now. It's got the sum of the x's right there, which is what you would get if you added up all the numbers. It's got the sum of the x squares. And now it has the number summary. It's got the minimum, 50,000. It's got the first quartile, 65,000. It's got the median, which was 90,000. Notice the median was easy to see here because it's the one right in the middle. Third quartile is 5,050,000. And the maximum is 10 million. So I think this illustrates you got to be very careful what you put in your calculator. You got to know how to key it in accurately and calculate the right statistics. So you need to practice this on homework. And I would say check your work. Does anybody have any examples where maybe you didn't check your work on some project or some situation and it caused issues? Anybody got an example?
Maybe not in this instance, but just using medical math.
I tell you, that's right. You got to try to do the right kind of thing, right?
Yes, sir.
And all the EMS work you do.
Well, it's just in the healthcare profession itself. I mean, you got your dosage on hand, your volume, and your desired dose that you need to give your patient. So, I mean, if you make a medical mistake on that, I mean, it could be detrimental. Because something like that, you give a medication, you can't just pull it out. I mean, it's there.
Right. And I guess sometimes calculations do have to be made, but I'm sure they've got procedures for how to do and administer just about everything. And it needs to be, even those procedures need to be calculated correctly.
Right.
I'll tell you an example. After I put up about 10 or 12 satellites, I've got a satellite failure I could tell you about sometime, but that's a longer story. But when I moved back to Atlanta from New York, New Jersey, I ran a undersea fiber optics design group at Bell Telephone Labs. And we designed fiber optic cable and fiber to carry really high speed data, which was the beginning of the internet as we know it back in 1995. And we had this new fiber, which was going to be the best there's ever been. And all the folks in my group were great mathematicians and engineers. And of course, they knew all the answers, and they thought they remembered all the equations and did all the calculations. So they were putting together the first run of a manufacturing line to manufacture fiber. And they did the first run and used up about $100,000 worth of material. And then they checked it, and it was wrong. The fiberglass was not correct, and it wasn't carrying the data right. And they checked it, and they messed up on a calculation. So one calculation that was messed up cost $100,000. And we didn't fire anybody. What they did was go back and do the right calculation, ran the fiber out, and it was right. And that year we sold about $3 billion worth. They made a lot of money then. So that was forgiven. But sometimes you don't get forgiven if you If it was my $100,000 that I lost, that was a lot of money to me. I'm sure it would be to y'all. But for our company, they were able, once in a while, you'll get scrap and stuff that you have to say, well, that's just a learning curve. Anyway, a lot of words there to say, be careful how you calculate and check your work. This is just a little graph of a box plot, the max, the min, the median, upper quartile, lower quartile. This little line here is called the whiskers. You can rotate this box plot horizontally if you want to. I'm going to end by just showing you a little bit of things we're going to be doing when you get into the practice test. And you guys already know about categorical and numerical data. Can anybody tell me let me write on this. The variable hair color of Dr. Brown's grandchildren, is it numerical or categorical? Somebody is watched the video, I'm sure, right? Miranda? Corey?
Is it categorical?
Right, it's categorical. The weight of a car is numerical. The variable, do you like ice cream, is categorical. I'm not going to go over this whole thing, but we'll be looking, you need to be able to interpret things like pie charts. You need to be able to interpret frequency charts. For instance, here is a medical thing where you're breaking up people into age groups. These are patients, I guess it could be men or women who suffered strokes. And there's just a question about what percentage you had strokes were in the 45 to 49 range. And you'll have to study this table a little bit. Notice I left out the frequency or how many data points there were there. Well, if there were a total of 25 data points, you add all these up, and what is it?
7, 10, 12, 13.
So that would be 5.
Yeah.
So 5 out of 25 is 1/5 or 20%. What's so funny? What's so funny?
I just missed that question right off the top of my head. I can't believe I just missed 5. Sorry. I apologize.
That's okay. Look, I can still make a lot of mistakes myself. So that's why I say check your work. There's some other questions on that same chart. Here is a bar chart with data in it. You'll probably be asked to answer questions about it. You may be given a pie chart and have to figure out if this is a pie chart for your company, how much was the printing cost on a overall budget of $128,000. We're not going to work all these. But now here's a lot of data where you need to calculate the mean. You'd have to calculate the mean of all this data. Now, wouldn't you rather put this in an L1? And so you can check it all out and then calculate it rather than just keying it into your calculator and losing it. But anyway, it's got all the answers here. And this is the practice test. Does anybody have any questions?
No, sir.
Okay. If nobody has any questions, I'm going to stop my share. I don't guess anybody knew it's coming. I'm going to end the meeting. Thanks for coming to the meeting. And if anybody has any questions they might want to ask me through email or texting me or anything, to work on your grades and everything else, just call me. I'm available anytime. So you guys take care, and it's a pleasure to see all of you.
Thank you.
Thank you.